In section 7.5, we're going to be solving exponential and logarithmic equations. So an exponential equation is any equation that you're looking at where the variable is in the exponent. And how we can solve for those ones is we're going to use a logarithm to get it out of the exponent so we can actually solve for our unknown value. So let's look at our first example. I want to solve the equation 16 to the 3x power equals 8. So since my x is kind of trapped in the exponent, how I'm going to get rid of it is I'm going to use a logarithm. Since 16 here is my base, I'm going to do log base 16. That's going to undo that exponent. So I'm going to take log base 16 on both sides, and now what's going to happen here is log base 16 of 16 is going to cancel. So now I can bring that 3x down from the exponent, and I'm left with 3x equals log base 16 of 8. For a lot of these questions, you're going to be getting some kind of weird decimals, so I would just leave that right side as log base 16 of 8 for now until the very end. My last step here, again, I'm solving for x. I want to get the x by itself. I'm going to divide both sides by 3. Now I'm going to plug that whole thing into my calculator. Log base 16 of 8 divided by 3 equals 1/4 or 0.25. What's also going to be important here in this section is to double check your answers. Just because since we're working with logarithms, which are kind of some new properties, it's just nice to kind of be able to double check and see that what you did was correct. So I'm going to double check here. I'm going to plug 0.25 in for x. 16 to the 3 times 0.25 power does in fact equal 8, so I know I'm good to go there. In another example, I want to solve 15 to the 3x power equals 285. In this example, my base is 15, so now I'm going to do log base 15 on both sides. Again, what's going to happen is that log base 15 of 15 is going to cancel, and I can bring that 3x down out of the exponent, and I'm left with 3x equals log base 15 of 285. Last step to get x by itself is I'm going to divide both sides by 3. Here I am going to get an ugly decimal, so I'm just going to take it out 4 places to round it. X is going to equal about 0.6958. In our second example, let's look at a real-world application to see how we could use a logarithmic equation. Wood is a sustainable resource when it's managed properly. Jaden owns a lumber company that has 1.2 million trees. He plans to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? So in this example, I'm going to be using that growth and decay formula that we learned in 7.1, where I have my starting amount times 1 minus or plus my rate to the t power. Here, since we're harvesting trees, I'm going to be doing 1 minus that rate. And now from here, I'm going to look at the information that they gave me and plug in what I know. So my starting amount is 1.2 million trees, so I'm going to put that in for my A value. Next, they're telling me that my rate is to get rid of 7% of the trees each year, so I'm going to do 1 minus 0.07. From here, I'm trying to figure out how long is it going to take to harvest half of the trees. So if I'm starting with 1.2 million, 1.2 million divided by 2 is 600,000. So I'm going to use this equation. I want to solve for t and see when that equals 600,000. So now I plugged in everything that I know. I'm solving for the amount of time, so for t. Since that t is in the exponent, I'm going to need to use logarithms and all that stuff to be able to get it out of it and actually solve for it. So before that, I'm just going to get that radical by itself. So I'm going to divide both sides by 1.2 million. And now I'm left with 0.5 equals 0.93 to the t power. What I did there is I changed 1 minus 0.07 to 0.3, so that's kind of where that comes from. Now, my last step is I want to get that t out of the exponent. So I'm going to take log base 0.93 on both sides. Why that log base 0.93 and 0.93 on the right are going to cancel out. And then when I plug that whole thing into my calculator, log base 0.93 of 0.5, I'm going to get around 9.55. So using that equation, using logarithms, I was able to figure out that it's going to take around 9.5 years for half of the forest or half of the lumber to be harvested. Last example that we'll look at today is solving for a logarithmic equation, so kind of working backwards here. Here I want to solve for log of 4x minus 3 equals 2. So whenever I see log with no base on that, Remember, the common log is log base 10. So if I see nothing, I can assume it's log base 10 of 4x minus 3 equals 2. And how I'm going to solve from here is I'm going to kind of use my knowledge from the beginning of this unit, changing something from logarithmic to exponential form, and then solve from there to get rid of that logarithm. So log base 10 of 4x minus 3 equals 2 can be rewritten as 10 to the second power equals 4x minus 3. From here, I can solve. I know that 10 squared is 100, and now I have just a basic algebra 1 problem. I'm going to add 3 on both sides. I'm going to divide both sides by 4, and I'm left with x equals 103 over 4.